Hi everybody, it's Professor Mitchell. Today we're talking about section 4.3, right triangle trigonometry. So I believe I mentioned at the beginning of 4.2 that there are three different ways to define the trigonometric functions. So the first one was using the unit circle. This one is going to be using right triangles. And in this section, we're going to be, I think, pretty much always talking about acute angles, angles between 0 and 90 degrees, or between 0 and pi over 2, depending on whether you're in degrees or radians. So in this section, we are doing what I just said, using right triangles to evaluate trigonometric functions. In this section, we're going to learn about pi over 6 and pi over 3, aka 30 degrees and 60 degrees. We already know about pi over 4. We're going to talk about what are called the cofunction identities. And we're going to solve some applied problems, which are kind of, well, they're kind of fun. That's all there is to it. Okay, so here's how this definition goes. I have a right triangle with the sides labeled A, B, and C. Now, most of the time when we talk about this right triangle definition, we call these sides opposite, adjacent, and hypotenuse. Those terms have to do with where are those sides relative to the angle we're talking about. So you're going to take one of the acute angles from your right triangle, and we're going to talk about the sine, the cosine, and the tangent of that angle. Okay? So the sine of that angle is the opposite divided by the hypotenuse. The cosine of that angle is the adjacent divided by the hypotenuse, and the tangent is the opposite over the adjacent. And they've also written it in terms of A, B, and C. I will tell you that I never think of it in terms of A, B, and C. I always think of it in terms of opposite, hypotenuse, and adjacent. So a common way that people use to remember those definitions is, oh, and then I wanted to point this out too. So what I was going for in this picture was, it's two copies of the same picture. I just made one bigger than the other because I was trying to show you what they're saying here, which is that the value of the trigonometric function depends only on the size of the angle. It does not depend on the size of the triangle. This triangle is bigger than this triangle. Oh, I just noticed a flaw in this thing that I was trying to do. These sides would not be A, B, and C anymore. They would be bigger than A, B, and C. But these are ratios. The ratios will stay the same. Okay. All right. So this is what I was starting to say a moment ago. So a common way that people remember those right triangle definitions is SOHCAHTOA, which stands for sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. Okay, SOHCAHTOA. All right. Now, I have never been a huge fan of SOHCAHTOA. I mean, what is that? It's not even a real word. So my version of SOHCAHTOA, and I am not taking credit for making this up, I wish I could. My version of SOHCAHTOA is some old hippies came around here tripping on acid. Sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. Some old hippies came around here tripping on acid. That's how I remember that. All right, so I do not have a cute way of remembering these three. The way that you should remember these three is just from the last section. The cosecant is the reciprocal of the sine. These three functions are the reciprocals of sine, cosine, and tangent. So if you look at the other part of the definition, it said that the sine was some old hippies. It's the opposite over the hypotenuse. That means the cosecant has to be the reciprocal. It has to be the hypotenuse over the adjacent. All right, came around here. Cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent. Okay, that's how I remember those three. I don't have any other cute way of remembering it. Okay, so now we come to our example. They've given me this triangle where one side is labeled 3 and the other side is labeled 4. And they want me to find the values of the 6 trigonometric functions of theta. Okay? In other words, what is the sine of theta, the cosine of theta, the tangent of theta? What is the cosecant of theta, secant of theta, cotangent theta? Okay? So let's do sine first. The sine is the opposite over the hypotenuse. Oh, but we don't know the hypotenuse. See that? They haven't told us what the hypotenuse is, but we have the Pythagorean theorem. Pythagorean theorem says that a squared plus b squared equals c squared. So we'll use that to find our hypotenuse. So if a squared plus b squared equals c squared, that means a is 3, b is 4. So 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So c squared is 25, which means c is the square root of 25. C is 5. Okay, so now that we found c, I'm going to use my definition. The sine is, and it all comes up at once, the sine is the opposite over the hypotenuse. The opposite is 3, the hypotenuse is 5. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. Okay, so that's the some old hippies came around here tripping on acid. And then the cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine. The cotangent is the reciprocal of the tangent.